Live. Welcome to our monthly community stream. You can tell that this stream might be a little bit different than normal because I have real life people next to me and it's really exciting. I have Luke Wagner and Alex Crichton. We are here to talk about something really cool that happened last week. So Luke, what happened?
The component model and WASI reached their Preview 2 milestone, which is a thing we've been working on for just forever.
Long time.
A lot of stars had to come together and aligned. We were talking about implementations in multiple runtimes. We're talking about producer tool chains. We're talking about specifications. We're talking about a whole bunch of things coming together. And then finally last week, the subgroup in the WASM CG voted to say, yep, that is Preview 2. We're not done yet. There's a lot more work to do, but that's Preview 2, and forever, that is Preview 2. So now we can do some stability and stop breaking things all the time. And yeah, lots of stuff.
Yeah, so Alex, you played a critical role in this. A lot of the implementation between, gosh, so many things. I'm just going to rattle off and you can correct me which ones I miss. WIT bindings, so that it's really easy for us to generate bindings, link bindings between what we define with WIT, the WebAssembly interface types. That's our IDL. That's part of the thing that we standardize here. Then the next piece is WASM tools. That's the thing that understands how to parse all of that. That's another project within the Bytecode Alliance. And then third would be the runtime, WASM time, that you're a maintainer of. And so these implementations across between producer tool chains, the pieces that you consume from the guest code, and then also being able to run it within the host runtime. How long have you been working on that kind of stuff?
Too long. I don't think about it.
Well, but we did it. We should. It's a big deal.
I think I'd probably say, honestly, this dates back kind of like 2018 when I started working on WASM binding at the time. WASM binding was not mentioned there. It's not related to components at all. But that was sort of like the inception of a lot of the ideas here. A lot of the sort of where everything came from was WASM binding back then. So I'd probably say like 5 years. It's been a while.
5-ish years. But I think the concept of the component model, that's something that kind of like emerged right over these years. We didn't always have that. 2019 was when WASI Preview 1 came out. And that was kind of like that first major milestone for a lot of this work. But it was after 2019 when a lot of these ideas emerged. So Luke, I have a handy dandy quote from you that I want to bring up, defining what is the component model and what's a component.
Yeah, so because there was a lot of things that a component does and it is to different people. It's an elephant with many parts you could touch. So the definition I came up for this talk, what is a component, why I gave at WASMCon last year, was a standard, portable, lightweight, finely sandboxed, cross-language compositional module. Because there's standards there, we're trying to make a thing that's like agreed upon, so it's interoperable between lots of producer and consumer tool chains. It's got to be portable, runs a lot of places, just like WASM, and all the CPUs, all the operating systems, all the hardware. It's got to be lightweight. We want to spawn these things really quickly because that's why a lot of people are using WASM now. That's why it's awesome. We don't want to do like a Corba or a DCOM where it has all these expensive COM services or whatever they were running. It's the same kind of lightweight model as WASM. It needs to be sandbox, like really small, just like you can do with WASM. In fact, we're really leaning into that and saying, let's make applications out of lots of little small modules that are all have separate memory so they can't like corrupt each other and have like terrible supply chain attacks that take over the whole system. Let's make a cross language. We want to use lots of different languages to write WASM. Of course, it's like one of the big things, but it's surprisingly difficult to do and practice and actually like not have to do a ton of work. So let's try to like factor out a lot of that hard work. And compositional, we want to take these modules and like Lego block them together, and snap them together and actually have that just work. And that's also surprisingly difficult to make work in practice. So that's that's what all goes into a component.
So did we make that?
I think we're not done all the way yet.
Well, we got standard, portable, lightweight, finally set. Actually, yeah, we got almost all of it.
Yeah, there's still more work to do. Concurrency's got to do more work to be composable, but like it's pretty. Yeah, we've made good progress along all those.
I think that's a pretty big deal. I also dropped in a QR code to the keynote that you referred to. It is one of the ones that I saw show up a ton of times in the Hacker News when we announced that WASI Preview 2 launch. That was the one that everybody's like, okay, it's cool, but also you need to watch this talk so you can really understand it, bring it in. So that's, I love your diagrams in that one specifically. I think that
so many hours on Google Slides. Too many hours.
It was worth it, is what I'm saying. It was completely worth it. You're probably questioning yourself on like hour 40 at that point, but no, it was gold. Okay, so If somebody wanted to get started today on trying to build my first component, Alex, what would you tell them to do?
I would tell them, I think it's component-model.bytecodealliance.org. Go there. And that's got fantastic documentation. It's got a lot great intro to the component model to begin with, just kind of like high-level concepts, high-level everything. I think it has a couple sections for Python, JavaScript, and Rust, and then maybe C. I sort of forget. Compiling to a component, and it kind of walks you from there in terms of getting up your first component, running inside of a runtime like WASI or Jcode, all that fun stuff.
All right, I am quickly
That's
bringing this
I
up.
see you madly.
I am madly
generating
going, so
QR
just
codes.
keep talking. I mean,
All right.
so what does it actually look like when I build my first component? What are some of the top level commands? And then what's this thing called WASM serve?
Excellent question. So when you build a component, you're going to get a .wasm. That's it. Actually, it seems it kind of looks like a core wasm just from that perspective, but it actually internally has a bunch of core wasms inside of it. So a component is a layer around inside of core wasm. So it kind of looks similar, but you'll kind of like, if you kind of dig around the internals, you can play around with it. But to at least run inside of WASM, which is one of the runtimes that does have component support, you would run WASM run component.wasm, and that's kind of the same way you can set up WASM run any core WASM module as well. So if you use preview 1, looks very similar to components as well. And I think the idea is ingest, it kind of runs a little bit differently, but you have this whole separate new interfaces. You've got new stuff such as like I think TCP, UDP, a bunch of networking support. That's all inside of the WASM run by default. And then to add on to all this, what Bailey was just saying, a WASM serve. So this is where one of the features of the component model is with WIT, you have the concept of worlds, which is sort of what a component can use and what it's got to give you. So from a host's perspective, this is sort of what I'm going to give it when I run it and what it's got to give me to run it. So a command, which is sort of like the WASM run, I'm going to run a CLI app. You got like the whole Unix system. You got file system, you got sockets, you got clocks, branches, all that fun stuff. But and the function you give is a main function. It's just go run myself. But serve, however, is slightly different. It's based on servers. And so the idea is you're given the ability to make outgoing HTTP requests. You can still do randomness and clocks, but you don't have a file system. You don't necessarily have some of the utilities you'd expect, CLI, like sockets and whatnot. But you export a handle function, which is run on every single HTTP request. And so this is sort of a model for saying, I have a WASM module or component, and I would like to run an instance of that for every single HTTP request coming in. So you can have a server spinning up really quickly with WASM serve, where on every single HTTP request, you run your WASM code and kind of generate whatever response you want, streaming in, streaming out, all the fun bits there.
Awesome. So I noticed that we've got a handful of folks on the live stream. So if you have any questions, we are live. So please ask them, and I will direct it their way. So you just went through basically, hey, I can build a component, I can compose a component. We haven't talked about that actually, but we can also run it really well using WASM as our runtime. I need a little bit of an explainer, I think, on component compositions. I'm looking at you, Luke.
Yeah, well, there's lots of ways you might want to compose a component. There's different scenarios where composition comes up. So one is, I'm writing a component and I want to import another component, kind of like it was just a different package, like in a registry, kind of like I would just add it to my dependencies of my cargo toml or package.json. And so the tooling that is being built up, I don't know if it's fully done, but it is in progress and works a good bit and is working better, I think, all the time, is that I can just put a component in my cargo toml dependencies, and then the tooling will go fetch the component, look at its exported types, which are WITs, generate bindings in my source language that I can just call, again, as if it were just a package that was just in cargo or crates. So that's one way. And then the tool will, now that I have two components, the one I wrote and the one that I just pulled in from a registry, it will link those together and make one compound component that now contains those inside of it. And that composite is now like a linked component. So that's one way I can do linking. And that's kind of like similar to normal registry sorts of workflows that I'm used to. But another one that like really leans into some like really powerful stuff you can do with virtualization and parametric linking, the component model, is using WASM Compose. And so WASM Compose lets you take different components and kind of stitch them together in like a more controlled by you way, where you can be like, okay, you get this file system, you get this different file system, because I don't all have the same file system, or all sorts of other sorts of creative things I might want to do like that, or like, well, you want HTTP, but I got sockets, so I'm going to link in an implementation of HTTP in terms of sockets, or all sorts of stuff like that. And so for those more powerful scenarios, you can use WASM Compose, which is getting a new input language. At the moment, I think it takes like something in YAML. But Peter Hune has been working with a bunch of folks in Bytecode Alliance on a new language that like looks really nice and looks very witty, called It's called
That's a
WAC.
good one.
Called WebAssembly compositions. And so in that one, with nice syntax of like new and let's and some curly braces, you can just link them up and it looks really nice. And so that's like a new input language that is being worked on that makes it even more elegant to write and gives you even more power and control. And ultimately, you take this WAC and call WASM compose, and it spits out a new composite component that contains all the things you refer to in that composite. And now you can run that somewhere. And that place you're running it doesn't actually have to know that you did this composition. It's just running that one composite component. It has imports, it has exports, so it runs, the runtime doesn't even nor care that you linked all these things together. That's all like basically encapsulated in this component.
So you're saying I can take a component written in a language, any language, compose with a component that was written in some other language. So I can compose Rust plus Python, Go plus JavaScript.
Yeah.
I can just keep going. Okay with that. And how do they talk to each other on their interface boundaries? You said that. But is there something evil that another component can do to me? How do we protect ourselves from that?
Yeah, well, there's different sorts of evil that can be done. The most raw sort of evil is when you just corrupt somebody else's memory. You have a wild pointer write, a use after free, one of these other sorts of bugs, and all of a sudden you've corrupted some bytes that totally aren't yours, and now somebody else crashes somewhere, and you're like, why did that even happen? Debugging that's a nightmare. You have to, So that's the one we prevent really well, because we put each component in its own separate memory. And if you try to access outside of your memory, where you might have touched another component's memory, it just traps on you. It says, no, you violated the sandbox, kind of like you're in a process and they're in another process. Processes can't touch each other's memory. Well, neither can components, except for much lighter weight than processes. So we give you that degree of isolation, but without all the runtime overhead of the processes. So that's one sort of evil that can be done. There's the other sort is the indirect sort, where we're both, using the same shared resource, file system or secret store, config store. And that one, we give you, it's still possible, two different components can import the same thing, but we give you a little more control when you're linking these things together of who gets what. And this is where that WAC language comes in, where you're like, if you have multiple components and you want to say this one gets access to this, the secrets, and this one doesn't, you can say that very clearly and explicitly in WAC and know for like very sure that what components don't have access to.
I love that. So we basically get that. I'm gonna pull it up one more time, if you haven't caught it yet. That they're finally sandboxed. It's basically what you described there. That's how that works together, plus cross-language, and that is why they're components. You compose components together. I think that makes perfect sense. So we're basically done. We can just pack it up and go home. We don't need the Bytecode Alliance anymore, right?
Oh yeah, we're good.
Mission accomplished.
Mission accomplished. Yeah.
Floyd the banner.
I think we have a lot more we want to do, right? Do you
Oh, yeah.
mind running through some of your favorites?
Ooh, yeah, well, I've been talking a lot. Why don't you?
Oh no, you just take this one. This is I'm a little too near focused. We've done so much for Preview 2. I want to focus on that and like polish that. So I'll defer to you on this.
Well, that's a great thing too. It's taking some time to actually
true.
polish.
Oh, actually, no, hang on. I'll talk about this. So actually, in that regard, the thing that I want to do with the component model right now is primarily polish. We have a lot of work to do in terms of integrating this into languages. So for example, Rust is going to gain a Preview 2 target soon, and Preview 2 is kind of like WASI Preview 2 components, all of that, kind of flesh all that out, get a really nice, buttery, smooth user experience. Go the same way with kind of WASI Preview 1. So like that's a huge goal. And not only that, but also Python and Ruby and JavaScript and many other languages go with this at the same time are all lined up. I want to get a really nice experience for getting the exact as components are right now, kind of fix out all bugs, make all the compositional properties work. I was just talking with a colleague of mine today. WASI Compose does have some work left to do in terms of various sorts of resources and things like that. But at least in my opinion, there's a lot of space we can explore just in the components that we do have right now. Now, that being said, there's always plenty more that we actually can add. There are very well-known open use cases that are not very well served with the component right now. And I'll defer to you for that.
Sure. Well, the big one that people run into as soon as they want to do really kind of real world components, and as soon as you're doing like real world components, especially in service scenarios, like streams all the places, streams coming in, the streams going out, splicing for all these streamy things. And right now, as soon as you start to do that, like we support it in WASI EHP, we can stream in all the directions with a high degree of concurrency, but you're like, this is not the most elegant bindings. I have to do a bunch of manual glue work, and when I have multiple components that are separately built, and I want to just like, I'm like, oh, I should just be able to link them together. Like, you can't. It kind of like interfaces are not quite the same. There's an asymmetry between what goes out, comes in, and as you try to just compose them, like we were just like hand waving and saying, oh yeah, you can always just do that. You're like, what? It doesn't work when I want to do the concurrency. And so, what we want to do is say, no, yeah, concurrency needs to be composable too. Just because I want concurrency doesn't mean I want to like throw away all this like all these lovely properties. So ultimately, after like spending a bunch, we have a bunch more work to do. There's a design kind of coming together. We're saying let's just have async functions be like a thing that you can just do in WITs, with futures and streams as just first-class types that you can put in your parameters and results. And once you have those basic things, the idea that functions can just be async and making that work in a language integrated way, and you've got these new types for futures and streams, a whole lot of bindings can now be done automatically. So we can just get ergonomic stuff without all this manual glue code. And then components can import and export the same interface. So now I can just like, again, snap them together, compose them together, and the composition goes back to just working, even when I want to be concurrent. So that's the big thing. It's it's a tall order. It's going to require just a whole bunch of like prototype, validate, experiment, feedback loop, just like we did with Preview 2, which was a long, arduous process. But I'm excited to do it and contribute to this back cycle. So that's a big thing. That's going to take a good chunk of time. But the good news is there's also all sorts of other stuff that does not block on Preview 3 that we can kind of in parallel in much smaller chunks and have much more finer grained releases before Preview 3. So we've been tentatively calling like 2.x, 2.1, 2.2. And so this can both be like new WASI interfaces. So there's a whole new dimension of that stuff of like this new functionality, but also even new incremental component model features, like we could add getters and setters to WIT syntax, so bindgen can give us nice getter setter syntax, and a bunch of other smaller things, adding maybe a dictionary type to it, adding optional imports and exports, it's not sure exactly what set of things we'll be able to have time to fit in this year, but there's a bunch of other stuff that based on feedback we can do in parallel with all this and concurrently with all this Preview 3 concurrency work.
Yeah, I think it's fantastic. So basically last week we launched WASI Preview 2. That's kind of what we're calling as this like major next increment in what we're able to do with WASI. If you're familiar with WASI Preview 1, you're probably thinking, oh my gosh, you mean you're going to keep doing more increments throughout the whole year? How? Why? That's going to break everything. But one of the cool things that we've added is that these interfaces are now modular. It's not one monolithic ABI. And now I can not only have modular interfaces, but they're also versioned. And that's how we're going to do this 2.x release. And I think the first thing we're going to do, using Alex's term, is make it buttery smooth. I personally don't quite care what's in 2.1. What I care about is that we deliver it quickly and then it doesn't break the whole world. And we're able to consume it. And I think it's going to be very happy. And I keep looking at Alex. So I'm like, you're going to give me that, right?
Oh, yes, Steph. I mean, I do actually, I want to emphasize what Luke was just saying in terms of one of the major goals of Preview 2 was the ability to do all this work in parallel now. We have had so much synchronous work happening that nothing can really progress until everything is done with Preview 2, but that's a wrap. We're now at a point where you have this sense of stability where all of these features are guaranteed. We're pretty sure we're not going to break into these things for quite some time. I mean, we're talking timescales 5-10 years at this point, if at all. And so this is sort of the breaking point where now we can actually start doing all this work. We can do key value, we can do async, we can do kind of all this language support. All of that can happen in parallel, shared basis of Preview 2, and that's like the major feature here at this point. So actually delivering Preview 2.1, we still got some work to do on that one to make that nice and smooth, but we'll get there. We'll get there.
Yeah, I think that'll be a huge improvement to basically working years to hit our next thing. But it was worth it, and we're going to prove it that it was worth it with 2.1. And then maybe several other releases going in. Something else that you said, Luke, there I think is really important to highlight is that there are so many different additive changes that we wanted to add or could add or need to add based on what people find when they start using this stuff, right? So I really encourage everybody on the call, anybody watching later, please participate, please pull this stuff in, give us feedback, because we have an opportunity here to make incremental progress as we get things coming in. So we actually have a real question, and I'm pretty sure it's going to be your problem. So
all right.
Here it is. Is there a guide for how to preview to IFI, a new C runtime like Lua, and there might be stages that are kind of obvious on how to do this. I actually will try to find, while you're talking, a link from Nick Fitzgerald. He actually walked through kind of some of the stages that he had added inside WASM time, but I think you know that off the top of your head, so please take this one away.
Definitely. So I'm going to interpret the question as kind of taking a C. When you say C runtime like Lua, please correct me if I'm wrong, but I'm thinking you want to compile Lua to a component, and you want Lua to kind of run inside of a component. So you kind of want to take a Lua program, compile it to a component, then you can run that inside of other host runtimes. If that's wrong, please let me know, and I can talk even more after this. But from that perspective, I think so. Getting started with Preview 1 is a great starting point. If you can already compile to Preview 1, you can already compile to Preview 2. You already mentioned we have these adapters, and we already have these in terms for running on the proxy world, running in the command world, and that's where you can take existing Preview 1 code and compile that to a component. This is actually a really important aspect of the transitional story from Preview 1 to Preview 2. We understand that Preview 1 has been around for 5 years. A lot of people are using it. It's quite large. There's lots of users doing lots of fun stuff. We don't want to just leave all that behind. And so we have the ability to take all that existing code and then run that seamlessly in the component model as well. It doesn't necessarily have sort of like native component support, but it definitely has sort of enough complete component support. So in that sense, the main transition story for transitioning your runtime like Lua, if it were compiled to Preview 1, would basically be to go through each of the Preview 1 imports and kind of whittle those down and then replace those Preview 2 imports instead. This does involve WIT bigen. There is a C generator, and it generates a nice header file. If you find kind of gaps with that, please let us know. There's lots of stuff we could improve, certainly on the C runtime specifically. But in general, it would be kind of taking those Preview 1s, replacing those with Preview 2s. You can do that incrementally over time. And then additionally, you can also get new access to the new features such as TCP sockets and things like that. So that's actually how the Rust standard library is likely going to progress, which is we're going to add a Preview 2 target. It still uses Preview 1 APIs, the standard library, and then it's going to immediately try and use the new TCP and UDP APIs, and then we'll slowly over time replace all the Preview 1 stuff with all the Preview 2 stuff, so it's sort of like natively Preview 2 at that point. So this is when I look back at the screen. I haven't heard that I'm wrong just yet in terms of my interpretation. So at least that's my high level.
We loved it. We loved it. Okay. The only other thing I'm gonna drop in here and add is that if you're interested in getting started on doing other languages, yes, I have. You can't see it on the camera right now, but I'm surrounded by experts, so it's actually really awesome. We are here for the Bytecode Alliance Plumber Summit, and so we've also co-located a WASI Triangle meetup because we're in Raleigh, North Carolina, my backyard. Whoop! And also this, if you know what that means for Go Wolfpack. But we are we're here running our normal community stream, and so Robin in the audience, who is one of the chairs for the SIG guest languages, I just dropped the URL to see where our meetings are for this. But basically, we've found that there are a lot of common patterns that people are employing, maybe even common tools for being able to add component model support, WASI Preview 2 support to different languages and language tool chains. And so a call to action would be to come and participate in that if you're interested in adding Lua. There is one other aspect here I'll add for Lua specifically, is the pattern that we've seen for both Python and Ruby usually starts with compiling the interpreter to WebAssembly, step 1. Lua is something that's been done before. I believe actually if you go to Single Store Labs, there's a really cool dude named Kevin Smith who has done a prototype of this, and I think a few other people have as well. So there's typically some person pioneering out there that's probably done this part of it, but the challenge is always to make sure you get your stuff upstreamed into a community, into some kind of open governance, or into the for real upstream language tool chain, because that makes it available for everybody. Otherwise, it's kind of hard to find, and it's a little bit hard to maintain. So I really would love it if WebAssembly showed up everywhere. That's kind of the goal here, I think. So yeah, I think I haven't seen any other questions come in through the chat, so I think you nailed it. Thank you. So, all right, we said what basically what Preview 2 is, how to componentize something, what a component is, but we didn't talk about what Preview 3 is. Do you want to talk through that?
Yeah. Well, let's say we got these great async functions with futures and streams. A lot of our Preview 2 WASI interfaces could be radically improved and simplified, and so the idea of Preview 3 is let's revisit these interfaces and say how much simpler and more concise, composable can we make them taking advantage of these new additions to the component model. And so because they're in Preview 3 and we have versions in our interfaces, hosts don't have to break Preview 2. They can keep supporting Preview 2 alongside Preview 3. Probably their implementations can very quickly funnel down to a shared common implementation. And then over time, let's say you want to drop the Preview 2, but you don't want to break anyone who's maybe stragglers who are still on those Preview 2. We will be building tools to help you adapt Preview 2 components into Preview 3 components by wrapping them. So that way you can kind of just transparently migrate any remaining Preview 2 code to Preview 3. But basically the idea is to redo their existing Preview 2 WASI interfaces, taking advantage of the new async support.
Excellent. Yeah. So would you say that Preview 3 then has breaking changes?
Well, it's subtle. That's the word because it sounds like bad, like, oh, we're going to break the world. But because of this cool plan, we're not going to break anybody. We're just going to like offer this new, better path and then a very good on-ramp to get there. So breaking in a sense of we're making a new major version, but we're not taking away the old version. So I don't know how that.
I think the way that I would phrase it is if you're familiar with Rust additions, that's sort of probably the closest analog that I could think of. And the way that I think really kind of captures it is that within one component, you can have stuff using Preview 2 and Preview 3, which means that you don't have to upgrade everything atomically. You can have some stuff still using Preview 2, maybe with an adapter, kind of get everything to work out there. But that's the major idea of kind of within one coherent component, you can have both at the same time. And that makes really nice incremental progress and everything.
So guys, is there anything I forgot to ask you on the stream while we're here? That's kind of a hard question, isn't it? It's just, I feel like there's so much to cover. There's so much to celebrate. And I have you two here. I feel like I should be picking your brains, but I'm going to pause because I know that our viewer online said that we nailed our answer. So please ask one more. Here we go. Yes. Okay. I knew it. So do we have a feel for when we might see more WASM component registry availability? And would a group like the Bytecode Alliance have a more centralist instance to publish to? Luke?
That's probably you and that one.
Yeah, well, there's been a lot of great work in the SIG registry over the last couple of years. There's going to be a lot more work. I think, yeah, that is a goal to have a public registry. It's a when you try to learn from the lessons of like NPM, it gives us some trepidation of just like being like, anyone can publish, just go nuts. Does everyone just, it's an FTP server. So we're trying to go about it carefully and diligently. Yeah, that's definitely a goal. I think there's going to be a lot of progress over this year. Definitely a lot of this component work is laying a foundation for like, what are we even publishing to a registry? How do we achieve these, this registry of packages implemented in different languages, and what is the unit of thing, the code that we're packaging? Well, now it's a component. We have got a clear answer for that. And we even in the component model have answers for like, what does it look like when I publish a component that has dependency on another component published in a registry? So all sorts of groundwork has been laid. So yeah, I expect this year we'll, try to capitalize on that and actually like build this thing.
Yeah, we've got some pretty sweet prototypes out there now that make it really easy to onboard once you have a registry. So expect more soon here, definitely. So I think that does a little bit of our wrap up. That's the big stuff. That's kind of the high level rocks. Where can they find us next? So that you can always find us on GitHub, on the Bytecode Alliance organization. We're on Zulip. All of us are on there, very active. And then I would also say that there's some major events coming up. So WASM.io is going to be in Barcelona. That's March 14th and 15th. And then WASM Day is going to be in Paris. That is, I believe, the 19th. It's the following week, which is kind of great and convenient and gives you an excuse to stay in Europe extra longer if you're not normally in Europe.
It's true.
Neat. Are you guys going to be at any of those events?
I'm going to try and make it to WASM.io for sure.
Totally. Nice.
I'm going to go to WASM as well. I think I'm going to talk about async there a whole lot more detail.
Oh, tell them the title of your talk. I love it. I love it.
It's kind of punny, but it's annoying because you have to like, ideally you see it right, but it's a stream of consciousness on the future of async in the component model, but it's a stream angle brackets of consciousness, angle brackets, future angle brackets async.
It's going to be great. That's what that means. Okay. All right. So that's our roundup. I don't see any more questions. So I want to thank Alex and Luke for joining me. Thank you guys, especially since I let you know that we were doing this today. So yeah, it was all a trap. I lured them here with a happy hour and then we got to hang out and it was totally worth it. So
This is fun.
yeah, thank you so much. All right.
Thanks for having us.
Thank you online.